Okay, our last question is about the final velocity of that rocket right before it hits the ground. We've already found the time that it takes not only to go up but also to go up and come back down. That was the final answer last time. We've also found the distance that it travels. So the final velocity of the rocket just before it hits the ground. I'm going to show you a different method you could use to solve this, okay? We want the final velocity when it hits the ground. We know that we know what the speed it gets launched at. We also know the speed at the very, very, very top. Okay, the speed at the very, very top, the speed is 0 at that point. So we could actually use that. Why don't we do this? We're looking for the final velocity at the very end. Why don't we start by thinking about the velocity of the rocket at the very top? I know before we said the initial velocity is 30, that's when it blasts up. But for this question, as we're looking for when the rocket hits the ground, why don't we start our initial speed? Okay, we're still doing the same problem. Why don't we consider our initial position, or our initial point, to be when the rocket is at the very top? Because we know that that is 0 meters per second. There's nothing wrong with doing that, with changing around your VF and VI. That's totally fine. Okay, you can totally do that. We need to know the acceleration. Up in the beginning of the problem, we stated that the acceleration was negative because we were saying up was positive. We can keep with that, so let's keep doing that. Let's keep saying that the acceleration is negative 9.81 meters per second squared. And we need to know, let's see, I do know the distance that it would fall because I know the height that it got up to. I know it's just going to fall back down that distance. But why don't we do this a different way? Why don't I just figure out, well, I know that from the last problem, when I solved it initially, I got 3.06 seconds for the time to go from the bottom up to the top. Well, I also know, because motion like this, where you have something coming up and going back down, is symmetric, I should know that as it goes up and comes back down, that it takes the same amount of time to go up as it does to come back down. So the time should be 3.06 seconds for it to fall back down. Let's see if we can plug this in and figure out what our final velocity should be. It looks like I could probably use the Fiat equation. So let's do that. VF equals VI plus AT. My initial speed is 0. VF is what I'm looking for. A, remember, is negative 9.81 meters per second squared. Don't get freaked out just because we have a negative here and we're going to get a negative answer. Think about what that means. The object is moving back down at this point, and we said up was positive. The answer should be negative. So 9.81 times 3.06 seconds. Now, when you multiply those, when you put them into a calculator, you should get, and I don't have it written down, so let me just check it. You should get a number that is really close to negative 30 meters per second. And I want you to consider that for a second. Does this make sense? Is this surprising at all? It shouldn't be. We talked about how when an object goes up and falls back down under free fall, we talked about how when it passes a certain height, it passes on the way up and the way back down, it will have the same velocity, the same speed, each time it passes that point, but the velocity will have opposite directions. One velocity will be up, the other one will be down. In other words, the magnitude should be the same. If this is the speed right before it hits, if this is the velocity right before it hits the ground, it makes perfect sense. We launched this rocket with a velocity of positive 30 meters per second. It makes sense when it gets back down to the same level that it would be negative 30. Same magnitude, but the opposite side. So again, this is equal, VF is equal in magnitude, opposite in direction to V, the velocity, from the launch. Now, there are many, many, many ways that you can do this, that you can do these problems. This is merely one way. As you get more practice, you will see more and more ways that you can solve questions like this. Okay? That's it for now. Hope you have a good weekend. I will see you later.